Hello, everyone, and welcome to this NGI Salon organized by NGI Forward. I'm the scientific coordinator of the SFLAB project, and we are very happy that NGI Forward has invited another NGI project, SFLAB, to be with you. So let me immediately show the agenda. I think, Michael, you have the agenda ready, correct?
I have the agenda ready.
Excellent, thank you. So the agenda, first of all, I shall give a brief introduction about the SFLAB project. And of course, my purpose as the scientific coordinator, all you participants, I want to welcome you to join SFLAB, to use some of the great components that we have been building, and also to become a sub-grantee, because there are more sub-grants. And of course, what is a better way to attract you to SFLAB than to show you some of the results of SFLAB and some of our champions. So you can see the champions of SFLAB on the agenda. I will not introduce them. They can do that quite well themselves. And I will start sharing some slides with you about SFLAB. So one moment, please. And if I've done my work correctly, you can now see the SFLAB slides.
Perfect.
So SFLAB is a cascade funding project. What does cascade funding mean? That means that a lot of money from Europe is coming to the project. And I'm responsible, together with a whole team, to distribute this money over startups, innovators, innovating persons, academics, to build something beautiful. And in the case of SFLAB, the scope of the technology is SSI, self-sovereign identity. So just to show you, we have three categories of open calls: the infrastructure open calls and two types of business-oriented open calls. And today I'm going to advertise two open calls which have a deadline of the 7th of July, so just 3 weeks from now, where you can win up to 100 or 100, even 150,000 euro. But let's not talk about money, let's talk about content. So what's the thing that we're trying to achieve in this self-sovereign identity area? We are trying to build a European ecosystem of companies, organizations, innovators that work together and that have self-sovereign identity technology solutions that work together and that are interoperable and that are usable on a larger scale. So we want to achieve the network effect. So with our infrastructure open calls, we are developing SSI architecture, open source components, integration. We are doing interop testing, and I presume that our champions can tell you a bit more about that. But that's really about getting the technology ready. Then in the business-oriented open call number 1, which is just in its finalizing phases. Our champions have been developing products and services based on SSI on a commercial and competitive basis, and showing that self-sovereign identity technology is actually something that you can make money of. And then the business open call number 2, which is one that, like the infrastructure open call, has a deadline on the 7th of July. This is about sector-specific and application-specific functionality and software, again on a commercial and competitive basis, where we are actually applying this, for instance, in the health sector, the e-government sector, etc. So let's first look at the business-oriented call number 2. The key word here is SSI Assurance Community. So when you share a diploma, and the diploma has a signature of a university, then, for instance, your future employer wants to know, is the signature real? Is the university real? Is the diploma genuine? And of course, are you the person that belongs to the diploma? For that type of thing, you need assurances, and you need to collaborate to provide those assurances. So typically an assurance community could be a community of collaborating universities of a country. Maybe it's something organized by the government, but very often it's something organized just by a local group of issuers, holders, and or verifiers. And what they provide is assurances about the credentials and the parties in their system. So this has three aspects: technical, legal, governance, and business. Within an assurance community, of course, you need to know what technology you're talking about, but also you need to have arrangements, for instance, accreditation, certifications, which is a governance thing. And of course, there's a business model, because everything holding this together, it takes money, so money needs to be earned. So what we are looking for are proposals for developing and demonstrating SSI working solutions in a real-world domain-oriented problem or opportunity, and then specifically in e-health, e-government, or education technology, but if you have any other area as well. And please make sure that you make clear what type of SSI assurance community you're talking about, so with whom you're collaborating to make this work. So this was about the business-oriented call. We also have the infrastructure-oriented call, and our third and final call, same deadline, the 7th of July. We are calling for open source solutions that protect citizens. So these are just examples: solutions for guardianship and representation. Not everybody in the world has a smartphone. Maybe you're too young, you're handicapped, you're unable because of one or another reason. So can you find solutions and technologies that help there? Also, protection against coercion. It will become very easy to share your diploma, for instance, or your health credentials with SSI. But this is a risk. The risk of the 800-pound gorilla that says, well, please share everything that you have. And what do you give to an 800-pound gorilla? Of course, anything it asks for. So we are looking for both technical and governance solutions to help protect citizens against this coercion. Another thing is communication, privacy, and confidentiality. This is already partly built in the DITCOM technology, but we are really looking for open source implementations. Anyway, you see tooling for assurance communities and many other things. So these are just examples of the thing that we are looking for. But other proposals are welcome. They should have added value to this European self-sovereign identity ecosystem. So please surprise us. As for procedures, I have mentioned the deadline already too many times, the 7th of July. After you have submitted your proposal, and don't worry about the proposal, it's just some fields where you have 1,000 letters to fill in, and just explain what is your excellent idea, what is the team, how you're organizing it, etc. Then we will do some internal checks, for instance, eligibility. We don't accept entries from China or Africa. It needs to be European. Minimum quality check. So do you qualify, for instance, in the case of assurance communities, have you identified your assurance community? Once that has happened, we have a bunch of external experts that check your proposal on 3 criteria: excellence, organization, and impact. Then we will come to some consensus, which are the parties that we invite. We invite you to sign an agreement with us because we need to send money to you, and then there's a kickoff. So there is a lot of hyperlinks about this. We will make my presentation available after this meeting, so please click on the links to apply. Please read the guide for applicants. Contact the help desk if you have any questions. And tomorrow at 11 in the morning, we have a question and answer session. So this was just my brief introduction, and tomorrow there is plenty of opportunity for questions. And this is already the end of my introduction, and I would like to give the word to the next speaker. And is that Rachel, correct? Or is it Michael who takes the floor now?
I'll quickly step in, yes, and like to also thank everyone. So can you see my screen now? Can you see my slides?
Yes, I believe so. Yes, now we can
It's
see
the
that.
I see the
agenda,
agenda
yes.
slide.
Oh, okay, that's perfect. Yeah, thanks a lot. So I just want to quickly thank you, Oscar, for the introduction and for also providing us with the SFLAB the forum or the funding for these projects that we would like to present you today. And also, of course, thanks to Gael and Rob from NGI Forum for providing us this forum here to present our results. So we'll quickly present the general challenge now. Rachel and me will present the lightest and trained approach to trust in digital transactions. So Oscar already quickly touched on this when he talked about these assurance, the challenge of assurance communities, or that we need this. So what is behind that is the challenge of trust in digital transactions, and we'll show how we approach this in two projects, an older one, and on top of this lightest project, we built a trained approach. After that, we'll bring this together. We'll show how different components of the NGI ESSIF-Lab interact together with Victor and Xavier. Victor from SIGPA and Xavier from Validated ID will show you how this interacts, how we work together in NGI ESSIF-Lab, and this all comes to culminates in the live demo, where we'll actually show how this can then look like with the European Health Insurance Card, an illustrative use case. So just let's quickly dive into it. And in the end, we have time for discussion, hopefully. So we'll just start with the challenge of trust in digital transactions. And for this, I'd like to hand over to my colleague, Rachel Salon, who has been in the lightest project, who has worked there for several years, and she'll present quickly this challenge that is behind all of the work, or most of the work that we are doing here. Please, Rachel.
Thank you very much. Yes, could you maybe go to the next slide?
Yes, sure.
Perfect. Yeah, so one of the biggest challenges in digital transactions is, of course, this root of trust. And for doing business or to provide services, we're increasingly relying on this digital transactions, whether it's between people or organizations or things and devices. And the big question or the big challenge is, how do we decide what's trustworthy? We can't see them, we can't feel them, and sometimes we can't even meet them. And what kind of things or tools can we use to decide what is trustworthy? And going on to the next slide. One approach is the trust infrastructures that are based on state-run regulatory processes, so EIDAS or like different governmental IDs, or infrastructures that they've built to kind of show their citizens, hey, you can use these services to accomplish some of your everyday processes with what we can provide you. However, these are often very limited to certain trust domains, and they're not really so flexible, centralized, and only partially compatible with decentralized approaches to trust. Next. And these are some of the motivations that Lightest had in its duration of its project. It was a project between 2016 and 2019. We had 14 different partners of academia and industry from 9 different countries, and it was coordinated by Fraunhofer. During this time, we had 2 pilots. One was with the Spanish Postal Service, and the other was with PEPAL, e-procurement pilot. But during this time, we constantly met different organizations and people who were interested in this same challenge and wanted to use this project or this idea as a way to demonstrate their own problems. So we also worked with the UNHCR, Industrial Data Space, and with the country of Azerbaijan. And along with that, so Lightest in a nutshell, the core idea is to try to find a way or to provide the parties that are involved in these electronic transactions with a means to automatically validate trust based on their own individual trust policies. In order to do that, we needed to develop or find a way that was lightweight, this global trust infrastructure, to be able to publish, query, or cross-jurisdiction translation of relevant information. One way to do this was to use an existing global trust infrastructure, which is the domain name system, which is what Lightest use. And using this already existing system helped enable us to retrieve and discover different ID information, and also assist in our tool that would help users or people to facilitate their own decision making. So here is the Lightest architecture. If you look in the bottom middle, the automatic trust verifier, this is the tool that we created in the project. And there's two aspects of this tool. The first aspect is what the user sees, or the verifier in this picture. And there's two basic functions. The first function is to be able to create your own individual trust policy. And this is basically just the user's preferences of who they trust, who they don't trust, and to what extent. And then the other is the actual electronic transactions that they want to conduct. And with this transaction, going up to the three different boxes, these are the three different ways that this transaction can be conducted. So it can be verified in the trust scheme publication authority, or it can be translated or delegated. And this was all based on this kind of GPS, or this finding of the DNS single trust root. And while the Lightest project is over, a lot of these ideas and these challenges and motivations, they're not. And I think this is probably a good handoff to my colleague, Michael, of what are we doing now and what can we do in the future. So.
Yeah, perfect. So thanks a lot, Rachel. So the Lightest project was more or less started before this whole SSI idea came up and became so big. And in Lightest, we did it in general with electronic transactions. And we worked, for example, with signed PDF documents or something. And then it came up, and we saw that but then came up this SSI, this whole idea of SSI. We learned from the ESSIF project, and I think most of the participants here know about SSI, self-sovereign identity. So we have this issuer, holder, and verifier approach, and it's a decentralized approach. But here we also, we also have this trust challenge. So we need to know who is behind a certain issuer, who is the real issuer. And we said, okay, it would be a cool idea to use our Lightest infrastructure and the building blocks to apply this for SSI and to bring this into SSI. And we saw that the ESSIF framework would be a cool way to test this and to experiment here. So just to sum up a little bit, what do we see as trust-related challenges in SSI approaches? SSI puts a very high emphasis on the user's control over the data. So this is also reflected in the principles of self-sovereign identities. But what is often not so well covered are the trust requirements of other relevant stakeholders. So, and they are, of course, also super important for the adoption of an identity technology. And what we see here is that the relying party service providers are of particular importance, because if you offer a certain service, they want you also to know, for example, will I get paid in the end? So who is behind a certain digital identity or credentials? So the trust-related challenge we see here is twofold. Let's say that there's a trust anchor challenge and a challenge to also integrate this into business processes. So we need automation for that. So what is this trust anchor challenge? So the trust anchor challenge is quickly illustrated here. So we have a web shop that wants to sell something, and we have a Tom who wants to buy something very expensive. So this is just an illustrated example. This can be realize probably differently, and don't worry too much about the SSI architecture. Now Tom needs a solvency credential, and for the web shop to buy something. He can either get it from his bank, but maybe he doesn't have enough money, so he could also go to a fake bank, and the fake bank just sells solvency credentials to Tom, and the web shop doesn't really know whether the fake bank, whether the credential that comes, it might be a cryptographically absolutely correct credential, but the web shop somehow has to know who is behind this bank. Like, is this bank a legitimate bank? And can he trust this bank, and not just the cryptographics? And for this, we need some kind of trust anchor, and this is a challenge that we see. The other challenge would be the challenge of automated trust management. So identity trust management is getting more and more complex. The identity information, the amount of it is steadily increasing. If you also look into the Internet of Things, the use cases are getting more and more complex, and we are crossing silos. And so the effort for the trust management across many domains is raising also. And one solution for this would be, of course, automation. And for automation, we would need some kind of trust policies that are in a formalized way, so that we can also automatically verify these types of policies. And this is another challenge that we see. So these are the challenges where we focus on with our lightest and trust approach. There are other challenges, of course, as well, but these are the challenges that we focus on here. Previous and related work to this, so we are of course not the only ones that thought of this challenge, would be to introduce a centralized governance layer, like you have with the very traditional certificate authorities or something. But this, of course, contradicts this open and decentralized SSI approach. You could also, of course, say, yeah, we'll just wait, we let the market decide. Only trustable banks will survive, or only trustable credential issuers in the long term would survive. But the fraud problem could always appear again, and it would make automation very, very difficult. Introducing hierarchical PKI, public key infrastructures, could also be a solution, but there's the question whether this is flexible and scalable enough for a large number of entities, and then the question of, do we accept a common root of trust? So where do we anchor all of this for this hierarchical PKI? We have to introduce this. And finally, one could also incorporate existing trust schemes, because we have something like EIDAS. So we could build an SSI to EIDAS bridge. And yeah, that's a very good idea, and we will show you how that this is also being done. But here we see the problem that this is often focused on a single trust domain. So SSI to EIDAS might work in Europe, but this wouldn't work for international trade outside of Europe, or also in areas where you don't need EIDAS IDs, for example. So we propose Train as a trust infrastructure approach. The aim is here that still everyone can issue credentials. The verifier decides. They can decide to consider supporting institutions for trust decision, and we can allow for automation through trust policies, trust schemes, levels of assurance, and so on. And for this, we have three main solution components. We have this automatic trust verifier components that can be used by the verifier to also run its policies. We have the Trust Scheme Publication Authority that publishes trust schemes and builds on an ETSI standard for trust list. And we have the DNSSEC as a common and already existing root of trust across domains, because everyone who's using more or less the internet is based on this. The solution, I hear some chat, but I cannot read anything. So if there's something, you can just shout to me probably. But is everything fine?
I think it's probably a question that we can use in the discussion.
Okay, great. So I'll just quickly present the Train approach here. So with our use case from before, one could say that there is something like a European Banking Federation that runs a TSPA and has a trust list. And in this trust list, all the banks that are real banks, more or less, that are part of the European Banking Federation are listed. And in the credential, there's now a pointer to in the solvency credential by Tom's Bank, there's a pointer to the trust list of the of the European Banking Federation, and the web shop using the ATV can query whether the solvency credential that is included here, whether the solvency credential is issued by a trustable bank that is included in the trust list that is maintained by the European Banking Federation. It could be also, of course, any kind of other company's registry. It could also be the EIDAS trust list or something like that. And the web shop can always also formulate trust policies, for example, that this is only relevant for transactions above a certain threshold. Of course, fake bank can still sell solvency credentials and can also claim to be in the European Banking Federation's trust list, but it will not be enrolled in this trust list, and so the transaction would fail. So what trading is and what it is not, it does not restrict anyone from issuing credentials, and the trust decision remains with the verifier, but the trading enables actors to use this global and known trust infrastructure to publish and retrieve trust-relevant informations, and it also allows to define self-defined policies to determine trust assurance level and make autonomous decisions. And this is based as a root of trust on the DNS using DNSSEC. We just want to highlight again, trust is very important here. Also the trust requirements of the verifiers, because they are also very important for adoption of SSI, as are the users. And this goes beyond cryptography and needs to be scalable. And we think that hierarchical and anarchic approaches alone are not convincing. And I'll speed up a little bit because we lost some time in the beginning. And I would like to go on to our next presentation already. So there's a lot of more information. We wrote a paper, and there's the GitLab for SFTrain in NGI ESSIF-Lab. Please contact me or us if you want more information, and we also have the discussion in the end. And quickly, we'll proceed to our second paper, or to the second part of the presentation. And for this, for the introduction, I'd like to hand on to Sami, I think.
Thank you very much. Maybe, Victor, you can start sharing your screen, or okay, it's the right one. Just for the demo, maybe.
Yeah, for the demo we have to switch, of course. Yeah. Yes.
So maybe, Victor, if you want to try to change, and well, I'm just gonna, while you prepare, I'm just gonna start for the sake of the time. So, well, hi everybody. My name is Xavier, and I work at Validated ID. And in the second part, we're gonna talk about the paper we submitted together with Michael and Victor regarding the use of different trust frameworks when using and verifying verifiable credentials. And within ESSIF-Lab, we have developed and integrated different SSI components, and we have defined an example demonstrate a situation where verifiable credentials could be used, and where, well, the use of or different trust framework is well clearly evident. So, well, we're going to start just with a quick introduction and the motivation about the paper that we published, and well, we're going to explain the different the use case and the roles that the different components play in the architecture, and then we'll showcase a little demo. And of course, if there are any questions, we will be more than happy. We will be more than happy to answer them. So, well, what are we trying to solve here? well, the main question, one of the main questions, as Michael has said, to be addressed when deploying SSI infrastructure is, well, how do we enable trust? How SSI can be deployed in a trust framework? And regarding trust, well, the lack of trust, as explained in the EDIS regulation, well, this can be due to a perceived lack of legal certainty, actually. So the question would be, how can we improve legal certainty in SSI? Well, we may need at least one legal framework or several, right? That defines clear levels of assurance that entities can enforce by the use of specific policies. And this is exactly something we want to showcase today using the different components. First, we'll be using SIGPA's infrastructure, which is an SSI bridge that supports different protocols and different DID methods to issue and validate credentials. Second, we'll be using a qualified electronic certificate that has been issued by a trust service provider under EIDAS to demonstrate how could we add some legal certainty to know who issued that credential. And finally, we'll be using the train component to apply the different policies to the credential issued and be able to verify these policies later. So maybe on the next slide we can see well, the use case that we want to showcase. This is an example we have chosen to demonstrate the different components and how could the European Union, well, it's just an illustrative use case, could leverage SSI to deliver the European health insurance card in its digital form. And here each national health provider would be responsible for issuing the card to its citizens. And cards could be used cross-border in different countries, applying a trust framework using the train infrastructure. And for that, well, now Victor is going to explain a little bit further the details of the demo and its different components. So please, Victor.
Thank you, Xavi. Maybe Michael, if you can move to the next one, and then
yes.
It's gonna be easier. Well, hello everyone. Yes, Xavi was saying today. I think for this demo. So before jumping into explaining all the components and the roles of these components, I think the idea behind this demo today is, I would say, three things. On one side, first of all, you know, how we can leverage EIDAS bridge to provide, you know, confirmation of identity of the user by using a qualified electronic certificate. Then also, you know, use the train approach as a way to verify that an issuer was authoritative to issue a verifiable credential, so it can be trusted by the verifier. And then really at the end, joining all this together as well with our issuance and verification services to prove and to show technical interoperability of an end-to-end process. And we think that the European health insurance card is, you know, it's a good example that outlines the need for an European governance framework when providing, you know, electronic services in a cross-border context. So, you know, holders or consumers can rely on authorities and the trust schemes to you know, provide the needed assurance of the service consumed. So, okay, let's discuss a little bit the diagram here. So, as you can see, this is the typical, more or less, SSI flow, where we have on the left side the issuer, then the holder and the verifier. But let's go first of the, let's say, different stakeholders and the roles. So, on the left side, we have the national health insurance provider, and the role is to issue the European health insurance card. And yeah, then in the middle we have the holder, which is the citizen, who is you know, is the consumer of this healthcare services. And then on the right side we have the verifier, or the healthcare provider as well, which, you know, is the one who's going to verify the health insurance card. Now, what are the components? So for the national health insurance provider, we use the issuance service and the SSI EI-bridge in order to not issue regular credentials, but as well qualified credentials. Then as well, there are two other stakeholders, which is the European Union and the national government. So the European Union is the one responsible to provide the trust framework for the cross-border usage of the European health insurance card. So in this case, the component is the train TSPA. So in this case, this TSPA so is responsible to develop and publish the different trust schemes. So for example, in the case of the European health insurance card, so the European Union is the TSPA and develops its own trust scheme. Then we have the national government, which is the one responsible for giving the accreditation of the national health insurance providers. Yeah, so it's responsible to maintain this list of trusted issuance and services. And yeah, in our case, so the TPA, it's, I would say, operated by each individual national European state member, or the national health insurance provider. And then, yeah, the TPA is responsible for including the different insurance providers of the respective countries in the trusted list. So they adhere to this trust schemes guideline issued by the European Commission. And then, so what is out of the scope for this demo is that on the issuance side, there is no programmatic way to, let's say, onboard or register the issuer in the trusted list. So this is out of the scope and has been done manually. But then on the verification side, dynamically, by using the automatic trust verifier, wrapped in an API for easy use, we are able to, from the credential, extract the issuer DID and the trusted list, which is embedded in the credential. And by having these two identifiers, the trusted list host and the issuer DID, then we are able to query the ATD or train to know if we can trust or not this issuer. Maybe if we move to the second slide. So, well, this is an example of a credential. As you can see here, well, it's compliant with the BC data model, and it's encoded in JSON LD. Here we have we define all the context. We have to define our own context for the European health insurance card vocabulary. Then we have the claims of the credential, and then finally we have as well the terms of use. The terms of use is a standard way defined in the BC data model to add this trusted scheme or trusted list that is embedded during the issuance for specifying the trusted list that the issuer is registered. And finally, here we have the proof, and in this case we have two proofs. One proof is the proof generated by the issuer, and the other one is the proof generated by SSI EI-bridge. Again, these two proofs in the future, there is a convergence, and maybe it could be one, but right now for the demo, we can handle two proofs, which is something also that it's part of the spec of the BC data model that allows to have multiple proofs. And if we go, okay, maybe now Xavi, I give the floor to Xavi, so he's gonna explain the OpenID CF protocol. Yeah. Just before you start the demo, because during the demo it's gonna be very fast, and we don't want to interrupt there. Just to take a minute to explain what's going to happen, okay? Because something that we also have integrated on this demo, which is actually the OpenID SIO protocol on the wallet, which stands for self-issued OpenID provider, and where the issuer and verifiers act as relying parties. And using this protocol, well, we achieve mutual authentication of both parties. And on the request, the verifier uses, a claims parameter, standard OpenID Connect parameter, request a presentation. And then on the response, what's going to happen is that the verified credential travels inside the ID token. And this is going to happen very fast, but it is
well, using a protocol that has been proposed in the community using widely well-known standard, which is OpenID Connect. So, Victor, whenever you want.
Okay, thank you. Let me share my screen. Can you see my screen?
Yes.
Yeah.
Perfect. Okay, so let's start the demo. Our journey starts here with the, let's say, a fictional Spanish citizen that is gonna request the European health insurance card to the, let's say, in this case, the Ministry of Social Security and Spanish Social Security and Inclusion. The idea here is that we wanted to provide different choices to the citizen or to the user, so different wallets. I'm gonna start the first flow, which is gonna demonstrate this integration that we have been talking about, and later also I'm gonna show you other flows, which for demonstrating other technologies or other types of moving credentials. So we are gonna start first with JSON-LD credentials and a browser wallet. So this, we are gonna move credentials using Chapi. Chapi is a web protocol for moving credentials. So let's start here. So the user, he's gonna select the wallet of his choice. In this case, he's selecting the web browser wallet, and the issuer is prompted to the user with the data that the credentials, the data that is about to issue to the user. Of course, here for this demo, the enrollment, it's out of the scope, so we need to assume that there has been a previous enrollment from the user, and the issuer has the data. So first of all, what we're going to do is a bit authentication. So here, what we're going to do is the issuer or the relying party is going to authenticate the wallet by a bit authentication. Once the wallet is authenticated, then the issuer is going to issue the credential to the wallet or to the citizen. So we select here the web-based wallet. We can review the credential that the issuer is about to issue to us. And also we can see that it's EIDAS compliant. Actually, we have developed as well a way to see the root of trust and see the qualified electronic seal and the qualified electronic certificate issued by in this case the FNMT, which is the Spanish EIDAS qualified issuer. So in this case, well, we are gonna confirm and accept the credential issued to us, and that's it. Then our journey continues. So in this case, the Spanish citizen is spending vacations in Paris, but for some reason he needs to consume some health services in a medical center in Paris. So in order to consume these services, so the process is the same. He's gonna select the wallet of his choice, and then automatically here the verifier is gonna request the European health insurance card credential, and the wallet is gonna ask for checking the credential. And here, well, let's see quickly the credential. So this is the credential, and if we see the source, we can see that it's a JSON-LD credential issued by the Ministry of Social Security and Inclusion in Spain, that it's anchored in DITSOC, and also that we have the ESSIL, which is this part here. Okay, so we are gonna proceed to share our credential. Again, here there is no selective disclosure or zero knowledge proof. We are gonna share the whole credential. And one is shared here, three things is gonna happen. First of all, we are gonna verify cryptographically the credential. Second, using the EIDAS bridge, we are gonna verify the ESSIL. And finally, as I explained before, by extracting the trusted list from the credential and the ID of the issuer, using train, we are verifying, we can know the verifier that it is a health insurance provider accredited by this trusted list, which is the European Union in this case. So this is one use case. Let's go to another one. Well, actually, what I'm gonna do is we're gonna go to the universal issuer. The universal issuer is a universal issuer where you can issue credentials anchored to different ledgers. This is actually provided by Danube Tech, which is actually a sub-guarantee from ESSIF-Lab. So, but in this case, we are gonna we're gonna use a random credential, employment credential. And we are going to get the potential issuers that we can use. And in this case, we are going to use an issuer that is anchored on Beres, is another blockchain. Okay, so we are going to issue this credential. This is a credential. It's not a European health card credential, it's an employment credential. But we are going to offer this credential to be a CHAPI as well to our wallet. And we are going to accept it. So now it's in our wallet. And now we're going to go again to our verifier, and we are going to present this credential to the service. Of course, the service is going to filter this. It's not going to show it to the wallet because it's asking for the European health insurance card. But okay, we're going to remove this filter, and we are going to share the employment credential. And what is going to happen here is, well, we are gonna so we have integrated here the universal resolver. So this means that we can resolve this DID anchor in another ledger, but then we cannot. We are not gonna say, look, this credential there is the e-seal, or we trust the issue. We just say, look, we just verify the credential cryptographically, and that's it. Okay, so this is one flow. Let's go back here. Now let's do another flow. So now I'm gonna do the OpenID Connect COP flow. So for this, I'm going to use the validated ID wallet. 1 second. So in the validated ID wallet, we have one credential. This is a self-attested credential with our email. This email is my Gmail actually. And then the first thing that we are going to do is what we are going to use the OpenID Connect mobile wallet provided by Validated ID. And the first thing that is prompted here is this QR code. This QR code is the COP request. We are going to proceed to scan this QR code. And then the wallet is asking us to provide to select our credential. Here, what is happening is in this COP request is triggering bit authentication. So here, both parties, the relying party and the wallet, is a mutual authentication. But also as part of COP protocol, the issuer or the relying party can ask for a claim. So in this case, it's providing is asking to the wallet to provide the email. So this is why we need to select here our credential and provide the email as part of this authentication. You can imagine that this is part of a business flow that the relying party has and needs this email for doing some checks. So we are gonna provide the email and do this DID authentication. And this is live, so it's not working. Let's try again. Let's see. So I'm gonna select it. Okay, here we go. And now once the DID authentication has been successful, then we can issue the credential. This credential is just a push notification that the issuer is gonna send to the credential to the wallet. So we just issue the credential. Here we ask for receiving the credential, and we should get the credential in a validated ID wallet. So we just accept it and we have it. And then we go to the verifier. So we have now the credential here. Now we go here to the verifier for the verification, and we just provide so when here we trigger again the same verification process, which is also a bit out, and at the end of this bit out process or COP request response process, the verifier is asking to the wallet to provide the health insurance card credential. So we scan here the QR code. It's asking for the European health cards insurance credential. We provide it to the verifier, and so we verify the credential. So this is the second flow using OpenID Connect and SEO. And finally, let's do the last one. So in this case, we are going to use ARIES technology and DITCOM, as mentioned before by Oscar. So in this case, we are going to use third-party wallet. We are going to use Isatus wallet, which support ARIES protocols. So okay, so we are gonna select here this ARIES or mobile wallet. So here, what the issuer is prompting us is a connection request. So this is to connect with the issuer. So we are gonna scan the QR code, and the wallet is gonna connect with the issuer. This is creating a mutually authenticated and encrypted connection between the wallet and the issuer. And now when we proceed to, so once this connection is established, then we can proceed to issue the credential. And we get the offer in the wallet, so we can review the credential that the issuer is offering to us. We accept it. And we have it in our wallet. We can go here, credentials, and we can see our credential. And then if we go to the verifier, so we select as well the mobile wallet, we can scan here. We connect with the verifier, and the verifier is gonna send us a proof request using this connection. Here because we're using Indie technology, it allows for selective disclosure and zero knowledge proof. For this demo, we are just asking the same claims as the other flows, but yeah, we could minimize the data that we need to disclose. So we are going to send we are going to share this information with the verifier, and so the verifier is able to verify cryptographically this proof. I think that's it. Thank you.
Yeah, perfect. Thanks a lot. Very smoothly. That went smoothly. So we demonstrated how to enable trust beyond this cryptographic verification. And we also demonstrated interoperability with various wallets. So it's pretty cool, I think. Of course, there are still some open issues like the initial enrollment, the governance of these trust schemes, or also what happens in case of the trust scheme changes and issues and credentials are already issued, so should we use short-lived credentials and stuff like that. And of course, the biggest issue always is also beyond technology, it's the adoption. So next steps would be to integrate this also in other SSI initiatives like Asset Trust over IP. This is why we are doing this. This is also why we are doing these seminars here. And I think with this, we already come to an end. And yeah, we have 4 minutes for questions, or maybe a few more. So I think we showed a lot. And yeah, I think this is it so far. I don't know how it works with questions here or with the moderators. We've had a question for Leitus in the question tab. Is it also possible to unmute people that they can talk with us? No, probably not. So I
have the feeling that we are on our own now, and that we have this very awkward text connection with our audience. And at this moment, we do not even know whether we have any audience.
Okay. Yeah. No, there are 22 people. I can see 22 people probably in the audience. So and Xavi is already answering the question on solving these problems with linked data of the trust architecture. So do you understand the question? I don't fully understand it. That's the problem. Mm-hmm. And I tried to answer the Henrik's question as well.
Not sure if he can speak. maybe he can maybe reformulate the question.
So it's good there is an audience. So so okay, yeah. So there are other propositions for solving this challenge. Yeah, I mean, I guess there are some other ideas. Thank you, Henry, for this. I will look at the at your solution as well. That we also have a call next week with people from Solid, so maybe they also can tell us more about this. Thanks a lot. And regarding the question of Henrik would be, yeah, I try to answer it here as well. If there's any addition to my or another question to my answer, Henrik, please feel free to add this here. I think it's a bit weird to answer to written questions or like this, or to discuss like this. I don't know how it usually works in this system. So
I see one question that's addressed to me, Loretta Anania. Yeah. She is the project officer of SFLAB, and she's of course curious how the open calls are going. Well, we can send her an overview of all the open applications. Of course, we don't have the deadline, but we have already several tens of applications. And one of the things that we have noticed is that especially the word of mouth by our subgrantees, so where our subgrantees are connecting to their business partners, that seems to be a very effective way of doing this ecosystem building. So I want to thank our champions, at least the 3 organizations that we have here, also for their help. And of course, I would like to pass the compliment. Here we have seen the integration of 3 different components from SFLAB in one single use case, and I'm very impressed.
Yeah, thanks a lot. Thank you very much. I think using our names, it will be very easy also to contact us via LinkedIn or just the old-fashioned websites using Google or whatever search engine you prefer. So please contact us if there are any more questions, and we can just speak directly instead of via chat. Thanks a lot to all of you. Thanks a lot to the audience, again to also NGI Forum for organizing this, and Oscar for joining us. I think we'll leave it with this.
Okay, Michael.
Have a great day.
Thank you, everybody. Bye.
Bye-bye.